friends, welcome to my YouTube channel. Today I am going to share my digital electronics. I hope you guys are liking my videos, and in previous videos I had explained about JFET with some numericals that are asked in the examination, and now today I am going to discuss something about digital electronics. What is digital electronics for us? For digital electronics, you can explain digital electronics in different names. That is, sometimes you can call it as logic design, sometimes you can call it as design circuit, and sometimes it is design logic. These are some different names of the digital electronics. In a digital in electronics, we are having analog and digital signals. Now I am going to explain you something about analog signal and digital signal. Analog signals are continuous signals. In our day-to-day life, analog signal are observed, for example, in temperature, velocity, etc., and they are having a value at some limited range. Suppose this is the graph for the analog signal. Here it is voltage and here it is time. This signal is the analog signal as I am showing you, and the lines that I had displayed with my black pen, you can see these lines are the some point at this some point we are getting some value about the analog signal. So this is the main graph of the analog signal that you have to remember. Analog signals are continuous in nature. Now I'll explain you something about digital signal. What is digital signal? Digital signal, as you guys all know about the digital signal is 0 and 1. Only two discrete values are there in the digital signal, that is 0 and 1. Is that changes at two discrete values, that is 0 or 1. This is the graph of the digital signal. You are at high value it is 1 and at the low it is 0. You can see, you can draw this graph and you can make the discrete signal. Discrete signal is 1 and 0 or 0 or 1. When the voltage, when it is high, it will be 1, and when it is low it will be 0. Two discrete values are used in digital signal, that is 0 and 1. In our electronics, in digital, we only explain the device only understand the language of digital, that is only 0 and 1. Now I am going to explain you something about the logic gates. Logic gates are one of the most important topic that is asked in the examination, in your engineering exams also, and for your net gate and other any entrance exam you are trying to prepare uh, for your engineering. Logic gates are also known as digital circuits. Logic gates are explained in the digital value and in the digital circuits. This is the diagram for the digital circuits. You can see 1 and 0. In high it is 1 and at low it is 0. 0 and 1. And this is the analog signal. You can't explain the logic gates in the analog signal. Only you will use that as digital circuit. There are some types of gates, and I hope you guys know about the gates. What are gates and how many types of gates are there? Basic gates, I'm telling you about the basic gates. Basic gates are AND gate, OR gate, NOT gate. These are the basic gates. With the help of these gates, you can explain. You can further use other. You can further use other gates. AND gate. First of all, I'll explain about you AND gate. This is the logic symbol for the AND gates. Here are the two inputs and the AND gate symbol. Y is equal to A dot B. This is the Boolean expression for AND gate. Boolean expression is Y is equal to A dot B. Truth table, and now I am going to explain about the truth table. Here you can see the expression, that is output is the input multiplication of the two inputs. So for the AND gate, your operation will be 0 0 0 dot 0, that is 0, 0 dot 1, that is 0, 1 dot 0, that is 0, and 1 dot 1 is 1. This is your main explanation of the truth table, and through this truth table you can learn how AND gate works. Next is the OR gate. The logic symbol for OR gate is this. You can see in OR gate you can have n number of inputs, A, B up till n, you can see here, and this is this logic symbol. Its Boolean expression is Y is equal to A plus B. That means the inputs you are getting, you have to plus them, and then you will be getting the output. In the OR gate, it is 0 plus 0, that is 0, 0 plus 1, that is 1, 1 plus 0 is 1, 1 plus 1, that is 1. You can't count it as 2 because it is digital, and in digital you are having only two values, that is 0 and 1. operation, or is represented by plus. Plus, you can see here it's plus. Okay, this is the explanation for the OR gate. And now I'm going to explain about the next, that is NOT gate. What is NOT gate? NOT gate, the symbol of NOT gate is this. You can see it has only one input and one output. You can see a bubble over here. This is the symbol for the NOT gate, and the bubble represents the NOT. Its Boolean expression is A is equal to A hyphen or bar, you can say anything else. NOT gate means an inverter. NOT gate means an inverter. That means if the input is 0, your output will be 1, and if your input is 1, your output will be 0. यानी कि उल्टा, अगर आपकी इनपुट 0 है तो आपका जो आउटपुट है वो 1 आ जाएगा, अगर आपका इनपुट 1 है तो आपका आउटपुट 0 आएगा. नॉट गेट इज ऑल्सो नोन एज इन्वर्टर, ये मैंने आपको पहले ही बता दिया. तो ये आपका नॉट गेट है. नेक्स्ट इज योर नैंड गेट. व्हाट इज नैंड गेट? First of all, NAND gate is the combination of your AND gate and your NOT gate. You can see as in the logic symbol, this is the NAND gate, and the bubble here represents that is from the NOT gate. Now this is the NAND gate, inputs and outputs. Its Boolean expression is y is equal to a dot b ka bar. Bar you can say, or you can say hyphen, anything you can say. This is the Boolean expression. And now NAND gate, you can see from the NAND gate you will get, you have to, bar means you have to inverse it. 0.0, that is 0 but your output will be 1. 0.1, that is 0 but your output will be 1. 1.0, that is 0 but your output will be 1. 1.1 is 1 but your output will be 0. NAND gate is also known as universal gate. It is because, why it is called universal gate? Because from NAND gate you can make OR gate, XOR gate, AND gate, etc. All these things you can make from the NAND gate. So that is why NAND gate is also called universal gate. Basically there are two universal gates. One is AND gate and the another one is NOR gate. Now I will explain about the NOR gate. This is the logic symbol for the NOR gate. You are getting the inputs and the output. The Boolean expression is this: y is equal to a plus b ka bar. NOR gate is nothing else but the inverse of OR gate, and the bubble you can see from here. This is the input 0 0 0 1 1 0 1 1, and the output for the NOR gate will be, you can see 0 plus 0 is 0, but by the because it is the inverse, so 0 plus 0 is 0 but the output will be 1. 0 plus 1 is 1 but the output will be 0. 1 plus 0 is 1 but the output will be 0. 1 plus 1 is 1 but the output will be 0. This is the truth table for the NOR gate, and NOR gate is also known as universal gate. Please do remember, sometime it is asked in exam. Please tell us what are the two universal gates. The two universal gates are NAND gate and the NOR gate. Now next there are two gates, that is XOR and XNOR. XOR gate. This is the symbol for the XOR gate. Logic symbol, you can see two inputs are there and this is the output A XOR B. Now this is the truth table for XOR gate. Now in XOR gate, what is the output? When there is the same input 0 0, the output will be 0, and when there is the different input 0 1, the output will be 1. So for 0 0 it is 0, for 0 1 it is 1, for 1 0 it is 1, and for 1 1 it is 0. This is the OR gate. Next is the XNOR gate. XNOR gate, there are two inputs. You can see the logic symbol, and the output is A XNOR B, the bar. In the output of XOR gate it is without bar, and the output of XNOR gate is with bar. And in XNOR gate the output will be, when the inputs are same 0 0, the output will be 1, and when the inputs are different 0 1, the output will be 0. So 0 0 for 1, 0 1 0, 1 0 0, 1 1 1. This is the output for the XNOR gate, and this is the truth table of XNOR gate. So this is all about the logic gates I had explained to you. Please do like and subscribe and share my video if it is helpful to you. And in the next video, I will be sharing some numericals on digital electronics from the papers of GATE and NET. So all the best for your exams and thank you so much.